Major uses of nuclear was the slide we left behind. Number one use for nuclear power is to do what?
Energy.
What kind? Electrical. I can't open these notes again, so I'm just typing over. The second use, and I wouldn't say it's second, another use is to make medicine. And a third use, anybody know? Let's forget about this one. I'm not even going to go over it. I want to go here. What are these things? Anybody know? Good. They're weapons, missiles, nuclear missiles. Or weapons, okay? Because that's definitely a use of nuclear power. So we know nuclear energy is main use is to make electricity, and we're going to go over how electricity is made using nuclear fuel, which is uranium-235. It's all I want you to know in this class is that uranium-235 is the starting nuclear fuel for a nuclear reactor to produce electricity. So this process that I'm going to show you right now is called nuclear fission. Please title that in your notes. Nuclear fission. What's happening in nuclear fission? Look at the little GIF. What? What hits a neutron? Look at it. Does uranium hit a neutron? Good. Neutron hits uranium-235. That's the first thing that happens. So where did this neutron come from? We literally are going to throw the neutron in there on purpose to hit the U-235. Anybody know to do what? To do what? Good. Split it. Because in fission, we're going to split the atom, right? So when the neutron hits U-235, U-235 is going to split into what we call daughter. There is a step here that I'm leaving out. If I feel like I have to give it to you, I'll give it to you before the AP exam, okay? But for this test, we're saying it splits into daughter U-235. What else happens when U-235 splits? Look at the GIF.
There's like a reaction.
What's happening in this reaction?
Energy.
What kind of energy?
Nuclear.
No. Thermal. Good. We've got heat energy being produced. What else? Good. 2 to 3 more neutrons are being produced. So after the new neutrons are made, what happens? The neutrons hit the U-235, and what's going to happen? Huh? It's going to produce more, what? I'll go back. More heat. What else? More neutrons. More U-235. At the end of this statement, I want you to put it's an uncontrollable chain reaction. Uncontrollable chain reaction. So if this is an uncontrollable chain reaction, what's not going to stop being produced? Heat. Heat, heat, more heat, more heat. What can end up happening? Well, heat is fire. Excess fire will do what to anything it's around? Burn it. And when something burns, like if this room burns, what happens to things? They kind of melt away and wither away. That's called a nuclear meltdown, okay? So if this is an uncontrollable chain reaction, something has to control it, or else we'd have nuclear meltdowns. So what I'm going to explain to you now is how the process takes place in the power plant. So this is fission. Fission occurs in a power plant inside a reactor core, and that's what I'm going to cover now. So this is nuclear power plant and how it works. You have to know every part of a nuclear power plant and everything that's going on in each part. So I'm going to start with this structure right here, which is called the containment structure. The containment structure or containment shell is thick. I'm talking about thick, possibly the size of this room, thick walls made of what? What kind? What's my strong steel? Platinum. That would be expensive nuclear reactor. Steel and concrete. And that is exactly right. They're trying to not only maintain the radiation inside the building, so they're going to use one of the strongest structures, but they're trying to make sure that if there's heat, there's a way to stop it from exiting, right? Where do we get steel from? In the industry. It's a byproduct of what? Coal. Interesting, huh? Okay. So inside this containment structure, which is the first line of defense from radiation leaks and meltdowns, is what we call the reactor core. This is the reactor core, also called the reactor vessel. It's where what's going to take place? Fission. It's where we put what's called fuel rods to produce fission. So these rods down here, these little sticks at the bottom, they're called fuel rods. At the top, believe it or not, is control rods. If I'm going to control fission, what am I controlling? The amount of neutrons. I'm going to absorb neutrons. I can't control the heat unless if I control the neutrons. So these rods go into the fuel rods and they absorb the neutrons and they basically say no more fission. It's getting too hot, right? And this is constantly going on. In addition, we have a coolant, which is water and other forms of liquid that are going to go through the reactor core to help control the heat as well because it's so much. This is actual picture. So these rods up here are my control rods, and down here, which is so big, this whole thing right here is packed with fuel rods, and inside are pellets of uranium undergoing fission. So these rods come in, and if you notice, they're inside certain parts of the reactor, controlling fission from taking place. Everything from here on is the same as coal. This is the difference, okay? So from here on is the same as coal, okay? Because the steam engine is a steam engine. It's what can we get to make steam? That's the initial thought, okay? So uranium is placed in fuel rods. What kind of energy is that? Remember, there's 6 forms of energy. No. Uranium-235 is nuclear. Good. So we start with nuclear energy. In a coal-powered plant, we start with what type of energy? In a coal, good. C for coal, C for chemical. Nuclear, nuclear. Then fission occurs. Where does fission occur? In the what?
Reactor vessel.
In what?
The contained reactor.
In the reactor core, in what? Fuel rods. So fission, the correct statement is fission occurs in fuel rods, which are found in the reactor vessel, which are encased by a containment structure, okay? So fission occurs to make what kind of energy? Heat. So we got our first energy transformation. Nuclear to heat. Yes? And then we add what? Good. Water to make? Steam, which does what? Spins the turbine, which is what form of energy? Nope. Spinning. Mechanical. Good. That turbine is attached to a generator, which sends what? Electrical energy to your home. Good. Now, in addition, there's 2 other structures of a nuclear power plant. We have a condenser, that's right here, which is used to kind of take back the water, which is great, because if we don't take back the water, what type of pollution occurs? Which is hot means thermal pollution. Good. Remember when you learned about that when we did water, thermal pollution is when power plants throw back the water. Good. We also have cooling towers that are going to capture heat because heat is lost during every energy transformation. So you have heat, 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 and they're capturing it so that the excess heat doesn't add, to problems with the containment structures and the whole power plant in general.